you'd like. 7 pieces, I believe, is the requirement. So, and we have plenty of drinks. If you have to use the restroom, it's down this hallway. I was informed that they put a sign up to let you know where the restrooms are. So I'm going to talk in a minute, but let me introduce Balaji from OpsMX. It was his brilliant idea to hold this meetup, to form this meetup. So without further ado, Balaji.
Thanks, Andy. Thank you, guys. I think so many people saw the eclipse today, at least partial. That's pretty good. I couldn't find the glasses. I went to Walmart in the middle of the night and they didn't have it, so I'm like, okay. I saw on Weather Channel, it's pretty good. Yeah. All right. So good evening, everybody. Thanks for coming. I think it's great to have everybody here, and thanks to Andy for organizing us and setting us up. I guess the reason why we did the Spinnaker Meetup here in South Bay was that there was a Spinnaker Meetup in the San Francisco. I hate to go up to San Francisco. You know, I spent 2 hours going up and 2 hours coming back. I'm like, you know what? Let's do one here. There's enough companies in the South Bay to form a meetup, and of course Netflix is here, so what better place to go. So we have 2 meetups today. So 2 talk today. Andy is going to obviously talk about essence of continuous delivery, and then we have Gopal, who is the CEO of OpsMX. He's going to talk about safety for continuous delivery. And we want to continue doing this meetups. So we want user stories. That's sort of my primary goal next time onwards, is to try to get user stories. So if you have anybody who's doing it, who's using Spinnaker and want to talk about the next meetup, happy to just hit me up or send me a message on Meetup. So without further ado.
All right. Thank you, sir. So real quick, I did get to talk to some of you, actually most of you. How many people here are using Spinnaker? Okay, and then the rest of you that didn't put your hands up, this is a Spinnaker meetup. Okay, we're good to go. The Tupperware meetup is next door. So the rest of you are familiar though with Spinnaker. Great. Okay, excellent. So yeah, once again, thanks for coming. My name is Andy Glover. I run delivery engineering here at Netflix, and I can't say enough how happy I am that we have a Spinnaker meetup in the South Bay. I love going up to the city being San Francisco as well. But yeah, I don't necessarily enjoy the traffic. That's a pretty good, well-received meetup. So I highly recommend look that meetup on meetup.com. I believe it's just called the Spinnaker Meetup, or North Bay, or San Francisco, or Bay Area Meetup. Pretty good meetup. So yeah, thanks again for everyone showing up. And I let me also just repeat, please eat the pizza and the salad. So I want to talk to you about the essence of continuous delivery. And before I go any further, I do want to just one disclaimer in that I'm not going to talk about the value of continuous delivery. I think we're all pretty much on the same page of what the value is, and I'm not here to question it. The value is speed, right? That is a amazing differentiator, competitive advantage. Obviously Netflix, but every company I believe represented here sees speed as a competitive advantage. And I can go into great length, and I'm happy to talk about, I'm happy to answer questions afterwards. But ultimately, why Netflix decided to invest in the platform. Sorry. Okay, sorry. So I'm happy to talk at great length afterwards if you would you like. So obviously you're at Netflix. I work at Netflix. There are a couple Netflixers here. Actually, there's more than a few Netflixers here. There's people from delivery engineering that work on Spinnaker. I'm really happy to say that there are people here that are users of Spinnaker that are ultimately the experts on Spinnaker. So again, I'm sure they're really happy for me to point them out and say that they'll answer questions. But I am happy that they're here. And so about 3 years ago, we embarked on a project to build a new continuous delivery platform. And Netflix had built a number of different continuous delivery systems over the years. So this effort was evolutionary. And we learned myriad lessons about what works and what doesn't through these other systems. And one of the key things we did with the Spinnaker project is we made a strategic decision to build this new platform with partners. And so we went out and we partnered with companies like Google. There's a consulting company called Kenzan that's actually based out of New York. We partnered with Microsoft and Pivotal. And ultimately, we ended up building this thing, Spinnaker, which is a pluggable continuous delivery platform. And we OSS'd, or we open sourced Spinnaker about 2 years ago now, as hopefully the people that raised their hand on the first question already realize. And I think that Spinnaker has been a success since open sourcing it, and I can certainly say that it's been a success at Netflix. One of the metrics that we leveraged, or we used early on to figure out kind of how successful this platform was, is we started measuring how many deployments we do a day. And we stopped counting essentially after 4,000. It was shortly after releasing Spinnaker, we were doing 2,000 deployments a day. Once we got to 4,000 deployments a day, like I said, we stopped counting. This is into multiple, AWS accounts. But I think what's interesting is that the deployment metric, it's certainly higher now, but I don't know what it is, because it's not all that important for me or for us to measure anymore. And hopefully you'll understand why that is by the end of this talk tonight. And I think a continuing factor in the success of Spinnaker is the big open source community, and there's a number of participants in that community here tonight, which is really awesome. I see, the Cloudera folks, Armory, OpsMX. This is awesome. Symantec. I'm probably missing someone, so forgive me. But Cisco's here. So this is awesome, and I think that's part of the reason why Spinnaker has been successful. And because of people like you, Netflix is looking at open source kind of differently, because our definition of success with respect to open source is kind of changing. Because we always viewed open source primarily as a means for recruiting and industry validation. But what we're seeing with Spinnaker in spades is innovation. Companies like Google, Symantec, you all are adding features into the core of Spinnaker that ultimately Netflix end users are taking advantage of, and this is tremendous. And so it's a give and take relationship, and then I suspect there's many innovations that we've added to Spinnaker that you potentially are taking advantage of, and vice versa. So it's great. And I threw this slide in here because I think this is kind of fun. In fact, Daniel from Armory is here, and we kind of worked this on the back of the napkin. I've given this presentation once before, so it's the old hat. You've seen this one before. I think it's important to note that this project is successful because the amount of investment going into Spinnaker. The last time I got together with Microsoft and Google, we kind of we did a back of the napkin kind of estimate in terms of how much R&D is going into Spinnaker on a yearly basis. And that back of the napkin estimate, then this was, I guess a year and a half ago, we came up with $40 million a year. And we revalidated it probably about 6 months ago, and it still holds true. And this is the investment that Netflix is putting into it: Oracle, Armory, Google, Microsoft, Target, Veritas, GoGo, Shipstead, and more, Symantec. So think of like the amount of just R&D, companies are that Cloudera. This is a tremendously amazing open source project with a whole lot of investment going into it. But, that's all well and good. And that was just kind of some like vanity metrics. So, thank you for indulging me. We'll get more serious and maybe a little sublime. Anyone here like hiking? It's the Bay Area. Like there's a million different places to hike or bike or run, whatever it is. So I was doing some thinking when I wrote this presentation that there are largely two different types of people in the world of hiking. There are those that are focused on the destination, and they anticipate a sense of accomplishment, once achieved. And then there are those that are less interested in the end, but far more enjoy the journey with little focus on the actual destination. I'm one of those people that just cares about the destination. If there's a hill, I just want to get to the top of the hill as quick as possible and then take my picture and then leave. I suspect there are people in the room that like love the journey up the hill and really enjoy it. And once you get to the hill, it's, hey, this is great. It was a great day. So when I see a mountain, all I see is a finish line. Keep that in mind because it'll help kind of define how I initially looked at continuous delivery. So again, I think we all know what continuous delivery is, but I'll throw out a definition. It's the discipline of building software such that it can be released into production anytime. And for me, and I think most of Netflix, the operative word in this definition is production. And I think it's the hook. It's the focal point that forms kind of like the strategic thrust of why we want continuous delivery. And I think you see this kind of realized in something like Spinnaker with, Netflix is all in with AWS, and Spinnaker as a project would not have been successful if it didn't facilitate deployments to AWS. And due to our tight relationship with Google, Spinnaker now offers first-class integration with Google Cloud Platform. And likewise, our partnership with Microsoft yielded an integration with Azure. But there are others. Titus. We support deployments to Netflix's own container cloud, which is called Titus. Think of it as like Kubernetes that Netflix built. First-class citizen in Spinnaker. Speaking of Kubernetes, Google added first-class deployments for Kubernetes. Target and Veritas, they joined forces and added OpenStack. The list keeps going. Google also added support for Google App Engine. Anyone actually use Google App Engine anymore? Silence is telling. All right. There was a few chuckles. I wonder how many chuckles I'll get out of this slide. Oracle has thrown their hat in the ring, and they've added Oracle bare metal cloud support. How many people knew Oracle had a cloud strategy? How many people knew Oracle was doing open source? It's awesome. Anyone here from Oracle? So the Oracle guys, the Oracle team, top notch, just an amazing team. They reached out to us and said, hey, look, we have customers that are demanding that our bare metal cloud strategies has Spinnaker integration. Or I should say, better worded, their strategy for rolling out bare metal cloud requires Spinnaker. That's awesome. So lo and behold, you've got first class support for Oracle bare metal cloud. It's kind of a tongue twister. But last but not least, Cerner, which is a large health information systems company, they added support for DCOS, which is essentially the commercial version of Mesos from Mesosphere. So this is there's a whole lot of integrations of Spinnaker that ultimately support that pluggability of endpoints. We can deploy basically anything to any cloud. So let's go back to that definition. I won't reread it because I think all of you can read. But I think there's a key word that I certainly overlooked because, again, when I see a mountain, I just want to get to the finish line, so to speak, to the top. And so I zeroed in initially on production. But the operative word, the essence of continuous delivery, is that word, released. And I think it's fitting that after this, OpsMX is going to come up and talk. Gopal is going to talk about Canary, right? Because Canary is part of this story. So there are two things that made me realize that the essence of continuous delivery is all about releases. And the first is about a year ago, about a year after we got Spinnaker up and running here at Netflix, there were a number of device teams that began using Spinnaker to orchestrate their deployments. And these deployments don't go to AWS. So how many people here use Netflix? If you didn't, please come see me. Yeah, so if you fire up Netflix, let's say on your smart TV, there's a firmware has been burned onto that TV before Sony basically shipped it to you or shipped it to Best Buy or whatever. And so there's a native app that fires up and it essentially downloads a web application. And that's the same roughly the same application if you use Netflix on your browser or on your TV. And so when I say the device team started using Spinnaker for their deployments, it's those teams. They were using Spinnaker to orchestrate deploying or delivering or releasing essentially a JavaScript application to Akamai. And what's interesting is they have a sophisticated release process that happens to leverage something we added into Spinnaker, automated canary analysis. And ACA informs them how to roll out new versions. So you can think of this largely as when we have a new release, let's say, of our core web app that, again, your smart TV or your PlayStation or your browser may use, we can roll out a certain percentage, let's say for Xboxes. We can say 10% of Xboxes get this new version. And then we can point our ACA service, and one of the gentlemen who, I should say, who wrote that service is here. And it'll spit out a bunch of metrics, and they can quickly determine whether or not, version 10 of Xbox is running well. And then if it is going well, then they can say, okay, let's roll out the remaining 90, or they can do it in stages. But they do all of this through Spinnaker. And this orchestration concept is key, because another aspect of Spinnaker's use caught my attention as well. And that was library owners. And in fact, one of those people, Greg, was primary in helping me realize this. There are teams that are publishing, client jars or ingesting other people's jars, and they've been fashioning pipelines to ensure sanity. That is, they validate dependencies using pipelines. And these pipelines may or may not actually even end in a deployment. And so CDN asset delivery and library pipelines, they weren't something that I had even envisioned from the outset. But it makes sense, right? Because if you think of Spinnaker as like a paved road, it's a super highway that others can plug into so that the majority at Netflix can start gaining value. And so, we've built in this flexibility to achieve these sorts of innovations. And even those innovations that, someone like me didn't even foresee. And since realizing the value of release in that definition, in the last few quarters, we've seen a number of interesting custom Netflix-specific stages plugged into Spinnaker. Things like CHAP. This is our chaos application platform. So this is a stage in Spinnaker that Netflix engineers can incorporate into their release process to ensure that they have all the proper fallbacks and whatnot in the event of like chaos happening, i.e., or for example, latency being introduced, or a service just completely going down. Another service which was integrated into Spinnaker is this thing called Byway. And Byway is basically custom request routing that facilitates very specific testing of features with like live traffic. So you can think of this as saying, I have an Xbox that has an ID of like 12, and I want to run a test in production with this Xbox and have a very unique path for this Xbox. And so with Byway, we can set up an auto scaling group that says, hey, for any request coming from an Xbox of ID 12, go to this particular ASG so that we can look at the metrics, or we can run some new kind of test on it. And then finally, another team started adding continuous integration capabilities into Spinnaker as a pipeline stage. And that completely obviates the need for Jenkins. And the thing is that things don't end there. In thinking of terms of release, we ended up adding support for properties. Property delivery. That is, this is the ability to change runtime application properties and validate that change via scope propagation. Again, this was not something this, delivery engineering ever set out to incorporate into Spinnaker. It wasn't even in our field of thought. And the platform team came to us and said, hey, we have an idea. If you think of, delivery as, a release process, then why aren't we using Spinnaker to roll out, fast properties? And I got a great example of why this is important at Netflix. Anyone here familiar with House of Cards? Watched House of Cards? A couple people. Used to be like everyone would raise their hand. Clearly, House of Cards, I think we're almost done with it. And so, the integration and actually the idea to use Spinnaker for fast property propagation came about from a specific incident that I want to share with you guys. And it was for House of of Cards Season 3. I don't know if you all remember, but because this was now like 2 years ago, but Netflix released Season 3 like 2 weeks early, and it was live on the service for like an hour. In fact, we didn't even know it was live on the service until like marketing or PR saw people tweeting it like, hey, House of Cards is live. Naturally we took it down. And the great story is that Netflix PR came out with a thing saying, hey, this is Washington, there's always leaks. So we totally got away with it. But the reason why House of Cards Season 3 went live early is because an engineer inadvertently changed a runtime property that propagated globally. Think of it as saying like live equals true. And while that engineer probably meant it to be, local to some like test environment, incidentally it went live and no one knew it. And it could have been worse, right? And we happen to, we own the rights, so to speak, or own, let's say, House of Cards. But if this had been like a Disney, or something we didn't own, we could have been in big trouble from a contractual standpoint in that, we're releasing this before the date is that we signed, this thing was live. So this was a great learning experience for engineering at Netflix, but it also seeded people in saying, we need to do a better job of rolling out fast properties, and we can use something like Spinnaker to do that. And so these lessons are causing us to evaluate or reevaluate our definition of what Spinnaker is and what we can do to still facilitate velocity for application owners. And this is where it starts to get really, really interesting. If you look at Spinnaker as a velocity facilitating platform, right, because that's what continuous delivery does, if you look at it through the lens of releases, one aspect becomes apparent. There are a whole lot of like dials and knobs when it comes to how this is done in Spinnaker. And so for those of you that are familiar with Spinnaker, you can basically configure Spinnaker to do pretty much anything, right? And in many ways, this is a result of where Netflix came from. Because we blazed a trail to go all in the cloud many years ago, and the engineers that did that learned everything about AWS, and that's reflected kind of in our ethos and in the tooling that we built at the time. You could select instance types, you could do X, Y, and Z. In fact, the predecessor of Spinnaker is a tool called Asgard that some people in the room may be familiar with. Asgard was largely like an AWS console kind of mirror. It did everything the console did, which was great because engineers, again, at Netflix, good people like Greg, knew everything about the cloud and said, hey, I want this control. But like all companies that are doing well, Netflix is growing. From the standpoint of the population of engineers coming to Netflix these days, they are less interested in the minutia of infrastructure. Like you can think of the generation that blazed the trail to the cloud, knew everything about infrastructure and leveraged the, infrastructure, to the max. But we have more and more developers coming to Netflix that are kind of like the Heroku generation. I do a git push and it goes live global. Why do I care about like instance types? And so things are complex enough, and these engineers, they actually want to be told how to get it done. There's too much complexity already. They just want to say, I don't want to figure out how to do my own release process. I want someone basically to tell me how to do it the best way because it's probably safe that way. So we've begun efforts, within Netflix in delivery engineering in partnership with guys like Greg, to build an intelligent system that will make many decisions for teams. And so let me give you an example. Aha. Come on in. 7 pieces of pizza, please. 8 for you. So let me give you an example. Think about this from the standpoint of a release process for we'll call it a tier 1 application. Everyone here familiar with like the term tiering? Do your companies also have like service tiers? So tier 1 is like obviously very important. Tier 1 at Netflix facilitates streaming. If a tier 1 service goes down, then it could affect your ability to watch Orange is the New Black tonight. Netflix is not in every AWS region. We're in some number more than 1, but less than 10. And if you're tier 1, you're going to be in all the regions, right? Because we're a global company. And so if you have an app that facilitates playback, you are in every region. And so regions really only matter from the standpoint of like a fault zone. But as an application owner, again, if you're a tier 1 app owner, it's just an abstraction you don't really need to care about because, again, you're global regardless. And let's say we're in, N regions today. If tomorrow we're in N+2, does it really matter to you as a tier 1 service? Because you're going to be in, N+2 anyways. And so if you start to ignore regions, we can start to do some super interesting things automatically. So first, we can perform squeeze testing. And this will ultimately inform auto-scaling rules. So squeeze testing is essentially stand up the app, hit it with as much load as possible, figure out where it dies, and then back off, and that's your maximum point, and that's how you auto-scale. We can also ensure the service is highly resilient via CHAP, which I already told you about. And then we can automatically canary the application. And Spinnaker can execute this pipeline in any region or in all the regions. It doesn't really matter. And in the event of a regional evacuation, which we regularly do, we can be smart enough to obviously disregard those particular results and indeed perform the whole thing somewhere else. Something you can't do today in Spinnaker. That is, if you run a canary pipeline in Spinnaker, you are right now defining, I want to run it in US East. We regularly, let's say, evacuate from US East, but we don't coordinate across these various teams. So if you are running a canary in US East, when we evacuate it, your canary will basically give you a 0 score, right? Because there's no traffic. We want to get away from that because that introduces load on end users that are leveraging Spinnaker. They shouldn't have to worry about this minutia. This should happen behind the scenes for them. And so the underpinnings of this concept are already delivered. And this is in the form of managed pipeline templates. These capture pipeline concepts that others can inherit. And certainly further work is being done. And the next step here is ultimately building some sort of metadata file that will ultimately inform expectations for an application. So think of it this way. Right now, if you're in the Spinnaker ecosystem, you're aware of managed pipeline templates. This is the ability to essentially have like a base class to say that my deployments are X, Y, and Z. And then any team can basically say, I want that base class, and they get X, Y, and Z, quote unquote, for free. But they could also say, but my org has a special requirement, so I'm going to add A to the beginning. So then their pipeline is A, X, Y, and Z. Some other team may extend the first one, and they'll add B, so it'd be B, X, Y, and Z. And the beauty here is in that the team that owns, let's say, the template that's X, Y, and Z, if they make changes to it, those changes can be propagated down to the service owners that are leveraging it. The metadata becomes really interesting. Is think back to, again, when I was talking about if you're a tier 1 app, you're going to be in all the regions. So we haven't built this yet. We hope to get to it in Q4. But the idea being is that an application owner can define a file up front. We've been calling it a .spinnaker file. And they can say, I'm a tier 1 app. And I require 30 gigs of memory. Hopefully not that much, but maybe. And I need a whole lot of disk space. And maybe some other things. And then ultimately, going back to that one diagram where I showed you with the 3 arrows, then Spinnaker can say, okay, you're tier 1, so we know we're going to put you in all the regions. You need 30 gigs of memory, so we'll put you in this sort of instance types where we have a whole lot of these things at a great price from AWS. And then your memory requirements as well. And maybe there's some other things in that metadata file. In fact, there certainly will be other things in that metadata file. In fact, we think there's going to be policies. So you might have some policies. I require that I be AACA'd and chapped or something like that. There'll be expectations like my expectation is that I support maybe SPS, which is as a key metric of I'm sorry. Not an expectation, but you'll define KPIs. So if you're a tier 1 app, you facilitate streaming starts per second, which is a key metric here at Netflix. You may say that as a tier 1, this is my KPI, or maybe my KPI is I require this much RPS. Whatever it is, you'll set all this stuff in a file, and ultimately Spinnaker will take that and say, okay, this is the pipelines we'll generate for you. So I definitely encourage you to check out this managed pipeline template spec. There are a number of teams already employing this at Netflix and kind of iterating on it. And actually in the open source world, there's a number of companies also using it. My understanding is Waze is actually probably the most advanced user of pipeline templates, which is awesome. And another key aspect of these pipeline templates is not only are tier 1, let's say AWS service teams using it, but remember those device teams I was talking about? They're also using this concept, and they, again, don't deploy to AWS, they deploy to a CDN. So I think, once application expectations are defined up front, we'll be able to ultimately even leverage a broker. In fact, this work is already being done in an effort to more effectively manage our trough and batch-oriented applications. So at Netflix, again, we have a very cyclic pattern. It's, it's 7 o'clock here in the West Coast, so everyone else except you all is watching Netflix. And so our traffic in the West Coast is going up, but in Europe, let's say, traffic is going down because ostensibly most people in Europe are in bed. And so we have a trough in Europe. And so we have all these reservations that we can ultimately leverage for batch-oriented things. So ultimately, Netflix is a data company, right? The streaming video is not all that challenging as Disney thinks. The real challenge, any Disney employees? I had to do that. Comcast? Hulu? Amazon? Come on. Sorry. What differentiates Netflix is our data, right? Is being able to predict and ultimately recommend what you should watch, and then ultimately also predict or recommend what we should buy or increasingly produce. That's a huge moat, so to speak. A lot of that is facilitated through batch-oriented computing. We ultimately want to do that at an efficient rate, and so we leverage the trough to do that. So earlier I said that deployments per day wasn't necessarily an interesting metric. And I hope now it's obvious why, because we're doing deployments to other things, right? We deploy to a CDN. We deploy to AWS. In the very near future, we'll be deploying to bare metal boxes that ultimately host the video that is pulled down when you press play. And so because of that, we as the operators of Spinnaker care less about deployments, let's say per day, and more about kind of the operations per second or per day. Again, because we have stages doing interesting things, that's that release aspect, and deployments are going to places, like I said, other than AWS. So the essence of continuous delivery is the journey and not the destination. It's ultimately how does continuous delivery affect or facilitate, your software getting into an environment. And I think once you think about release rather than deployment, it opens up a whole world of possibilities for how you can ultimately leverage Spinnaker or any other continuous delivery platform at your enterprise. And that's ultimately what we've seen at Netflix. Without further ado, should I take questions or do we want to have? Yeah, let's take some questions. Thank you very much for your patience. I always love it when no one has a question. And the second worst is when a Netflixer has a question. Yes, you over there, sir. Chris, how can I help you?
The person who released house cards early, they still with the company?
They are. In fact, that's a great question. Yes. So that person, that's to my knowledge, they're still here, but they were not fired because of that. In fact, Netflix has a blameless postmortem. We learned a ton of lessons from that. And ultimately, that person was, in fact, I don't even know who that person was per se. I don't know the name, but I know that they were not fired. Yes, sir.
So going back to the house of card question, right? As I say that the traffic goes up and down, right? Depending on which time zone that particular region is. So how do you, any changes when they happen, right? How do you propagate those changes or back out the changes?
Sure. So the question is if because of the trough, can you kind of control when deployments or changes or delivery happens? And the way we do that now is we have this notion of windows. We call them deployment windows, but really they are stage windows. So any stage in Spinnaker, you can say can only run during these hours. And so the Netflix, we've added some stuff on top of Spinnaker. So, and I can show you this afterwards. But if you're a developer at Netflix and you're building a pipeline, your deployment stage, we've integrated telemetry to tell you, okay, here you're doing it to this region, and here is the trough, and to give you that context, and you can say, hey, look, I only want to deploy this particular service in US East between the hours of, let's say, 10 a.m. and 1 p.m. Pacific. So what they're trying to do is do it before, peak, or in that case, I guess they do it a little earlier. So you can control that. We want to move to a world, though, where you don't have to define those things up front, because we are increasing, our members continue to grow. worldwide. And so there's probably a point where that trough isn't really apparent as it is now. And so we'll need to have a system, and we have the systems to do that. We'll integrate with Spinnaker to basically, you can essentially in a perfect world say, deploy this app to this region when traffic is lowest, and then we'll just do it automatically by reading, essentially, metrics from that region.
So there would be a possibility to establish a pattern.
Yep.
Depending on the traffic and then kind of.
Yeah, well, we certainly know that pattern now. Most of us foresee that pattern will probably become more noisy as more and more, members continue to enjoy Netflix outside the U.S. And so we'll probably need, more sophisticated systems to detect, let's say, the trough to deploy them.
Making that towards to the machine learning or the AI.
Sure. Yeah. The guy behind you hopefully will make it all work.
Second question.
And he's not looking for a job. Yes, sir.
So how far down the story are you for these managed templates?
How far? I would say we're pretty far. I mean, we're certainly not done. We're iterating on it. We have teams leveraging them here. I would say that probably the most sophisticated user of them is actually Waze. But I would suspect we will continue to invest in these. I shouldn't say suspect. We will definitely continue to invest in them. I think you'll see an uptick in Q4. We have 2 new people joining the team, and one of those people we've pegged to say, hey, look, we're going to put them right on managed pipeline templates.
So a follow-on question is like, how much work do you anticipate getting your development community to switch to this? They've all got like how many thousands of pipelines, right? It's going to take some time.
It's going to take time. I think this is. Were you going to say something?
Yeah, so
Real quick, this is Rob. He works on the team.
well, we have tooling that allows people to convert their current pipelines into something that you can easily adapt into templates. And adoption has been pretty good so far. People are actually kind of beating down the door to convert over to templates rather than it being like an initiative that we're having to drive.
Yeah, I would say it's definitely. In fact, I had a meeting today with leadership who said things are too complex. Engineers just want to be told ultimately how to do that, and he also sees the vision of I just want managed pipeline templates. So yeah, I think it's going to be a long process. We have automation around it, but it's not going to be terribly long. Yes, sir.
So what is the sophisticated?
What is the sophisticated?
What does it mean to be sophisticated?
Aha, that's a good question. That's probably just me embellishing. I would say that there are definitely established patterns at Netflix on how we do deployments. In fact, there's a gentleman behind you that you should ask. He's helped define a lot of those. And so ultimately what we see at Netflix is there are tier 1 teams that are kind of, let's say, leading edge in figuring out a proper way to do deployments. It's more than just like a red black, right? Or blue green. There are strategies leading up to it, and then afterwards, I mentioned kind of, let's say, CHAP and some other things to validate ACA. And so I would say that's sophisticated. That is a, let's say, nice template. For whatever reason, I'm tongue-tied. And people ultimately will look to these tier 1 teams, other teams, and say, I just really want to do what they do. And that's the real benefit of managed pipeline templates, because how they do it now is they go into Spinnaker and they're like, oh, I like this app called API. I know it's like a high-speed app. And they look at all their pipelines and they go, that's a good one. And then they basically copy it. And then invariably API evolves. They figure out a new best practice. They update all their pipelines. And that one team never got that memo. And now they have these old pipelines. Sophisticated. Yes, sir.
How does monitoring fit into these pipelines, or is that even a thought that?
So there is monitoring with respect to like health checks in terms of determining whether or not to move on to the next one when you do a deployment. There's a number of health checks, whether it be the AWS ELB registering discovery. There is a particular stage that we want to build that is ultimately a custom kind of health check where we basically say, hey, in our case, we have a telemetry system called Atlas. And you can essentially say, give this stage an Atlas query and then set your thresholds. And that would be a custom health check. Like once this metric is met, go on to the next one. Or if this metric doesn't exceed this or something like that. So there are definitely health checks per se of the service itself. being deployed, as opposed to a generic stage to say, just do this thing. You can do that actually with a webhook stage, I suppose, but we want to have a native stage to do that as well. And then there's ACA as well, which is highly, telemetrized. Yes, Greg.
Yeah, if I can say one thing about the switch to the pipeline templates is you found that we have so many pipelines and each one is slightly different. They've all grown up ad hoc and such. And so if we were to simply, use the automation and convert those into templates, 100 pipelines would become 100 slightly different templates. So we've slowed down the process a little to sort of look at them and say, what are the common use cases that we can maybe have 100 pipelines now distilled down into 5 templates or something like that. So it is a slow and thoughtful process, but at the end, we hope we'll have a smaller amount manageable.
Yeah, it's great. Great context. I think at this point, the last time I checked or asked, we have 9,000 templates, or not templates, pipelines. Is that number low now at this point?
Probably.
Yeah, a lot of pipelines. We envision a world where we don't have that many. We have, let's say, maybe a few hundred templates. I don't know.
So,
Yeah.
question on this. So if you have so many pipelines or so many different variations of a template, given what Spinnaker does, why isn't it more natural to say that just spin up a new pipeline, run it through and see what happens? And why isn't it faster to move? You mentioned it being very slow, thoughtful. Why can't it move a little faster?
Partly because each version of the pipeline is slightly different for some reason, and we have to understand, is that reason really important, or is it because someone just created it that way? If we were to take all these different similar pipelines and force them into one template, we might be missing some difference that needs to be there. So now we'll take that difference and maybe build it conditionally into the template, so that now that template covers that particular case.
I think it's probably also helpful to explain from the Netflix kind of the way we set up our teams. There is no central kind of DevOps or operations teams. Every service team has the responsibility to kind of, they own their own destiny. So every service team fashions their own pipelines. That's why you see a lot of variation. If there was a centralized org, I suspect there'd be fewer templates or fewer pipelines.
The question is not about the fact that there is not variation. I mean, I expect variation, that's fine. But Spinnaker, by the looks of it, seems to be. Oh, by the way, I know very little about Spinnaker. Just what you.
Hopefully know more now.
More than I did half an hour ago. But the notion that this looks very attractive, looks very, automated.
It is attractive.
Automation.
It looks it is.
But then, there is an implicit notion that there is significant automation in this workflow of pipeline.
Yeah.
And what is surprising or incongruent in that analysis is when you say that it's slow, I'm saying, wait, there is automation, it seems to be working, you seem to have all the pieces in place. You're saying it's kind of slow. That's not making
Slow.
But maybe I should go back and take another half-hour tutorial on Spinnaker before.
Did you hear slow as in the pipelines run slow?
No. The fact that if there is variation and there is automation, you should have greater confidence in being able to move faster when your attempt is to remove the variation. And the point is that the automation has to serve some purpose outside saying that I have 9,000 different flavors.
Sure. Okay.
Okay, I should probably just shut up now.
No, not at all.
So does these pipelines themselves have a UL date of life? For example, the variation I would imagine whatever would happen to the template, and by the virtue of that pipeline that's created, that variation stay there continuously, or will it go like end of life, or will
I'm not sure I understood the question.
So basically, a pipeline is like pretty much like a product itself. So every product has just like it starts out life, ends,
Yeah.
have an end of life.
Oh,
Somebody's using it somewhere.
Sure.
Do you advance? Do you
Well,
apply?
we do version pipelines. I think we haven't necessarily talked about how to end of life them, but that's an interesting aspect. I think we have much more ability to end of life pipelines once we get onto this template model. I would say now it's probably a little bit more difficult, but I suspect we could solve it. How's that? I hadn't really thought about it. Had you, Rob?
Not entirely, no.
Interesting concept. Very interesting. Yes, sir.
One more.
Sure.
I know it's.
I'm paid by the hour. You guys can ask questions all night.
I'm as simple as the gentleman, so if the question is too silly, just say so. So in terms of the monitoring question, how do you know the Spinnaker is doing the right thing at any given time? How do you know the health of the system itself?
The health of Spinnaker?
Yeah, so about the monitoring, right? So how do you know the Spinnaker is doing the right thing according, means you release Spinnaker, right? So there got to be bugging it, right? So when you release a new version, right? I mean, how do you know the Spinnaker is doing the right processing, etc.? And then you have a metric for that performance?
Certainly, yes. So yeah, we monitor Spinnaker just as tier 1 services monitor themselves. We have a series of test cases that we run through. We have pipelines that we continuously run. Is that?
Right. So on the runtime, so when
Yeah.
you deploy a new system, right? So
Yeah.
that's running, I'm running this new version, right? So how do I know what metrics do I have now? I know that the newer version is really doing a better job than the older one, the previous 5 one, etc.
Well, yeah, I think there's many variations of the answer to that question in terms of how do I know I'm doing better. I would say one of the one.
Not necessarily better. In terms of health, I mean, he's doing the job. He's running.
Yeah, and so ultimately, I would say the answer how we do that efficiently is we have a series of pipelines that we continuously run, and those pipelines validate that Spinnaker is doing X, Y, and Z for these teams. And so anytime if those pipelines break, then we know that we just had a regression, and hopefully we find it before our service teams do.
Appreciate it.
Happy to ask, chat in person.
No, that's fine. That's good.
Talk to that guy.
I guess.
I'm just kidding. I threw him under the bus.
Okay, perfect. Let's
Let's get you set up. Awesome. Thank you, guys.
Thanks, sir.
Yeah, we're just gonna leave going. So let's get you set up. So, do you want to plug? Or, if you want to take a second and grab some pizza, go for it. Be right there. Let me know. All right. So you good to go?
You can see it. No.
Good evening. I'm Gopal, Dommety. It's good. It's good. Okay. So, good evening. I'm Gopal, Dommety. So, if you think about the question, can I go fast without? I mean, if you really go fast, it's going to kill you if you don't have safety. I mean, if you think about it, and that's the question that really motivated us about a year ago when I first met Chris, and I learned about continuous delivery and how we want to speed up things. So the first question we asked is, how fast can we go without having automated judgment? Essentially, you need to have some way to automate your decision-making process. You need to have some way to determine if this new release is good or not. And beyond a certain speed and complexity, there's absolutely no way your human decisioning is going to cut it anymore. And that's what motivated us to look at this problem. So It's always hard to go after Andy, so I wanted a big break, and unfortunately I didn't get it. So let me start, and this is going to be a very technical sort of a presentation. We'll start with increasing safety through automated judgment. Either you do canary analysis or you do red-black. So you either have a manual analysis, you can use automated analysis to help you make better decisions, or you actually can automate your decision-making process. The second is we'll talk about Spinnaker's automated analysis and judgment stages, the AC and the canary, and I'd love help from Chris on this. And then configuring a Spinnaker, and then a Spinnaker demo. That's our thinking. So if you think about reducing the cost of failures, why do we do safe deployments? We essentially reduce the cost of failure. So we can do, most of you do, by the way, how many of you do red-black deployments? This is the Spinnaker folks. Sorry, the Netflix folks. Canary analysis. And I guess rolling updates. There you go. Thank you. So today, if you're using a Spinnaker pipeline, most of you are probably using some sort of a manual judgment. So this is a Spinnaker pipeline. You have a set of stages, you deploy, and then you have a manual judgment to say yes or no, and then you use it here to once you look at the metrics, then you decide whether this is good or not. So now, how do you actually make that? How do you decide? How do we manually judge? So we manually judge, or we make decisions either by looking at, definitely by looking at data. We look at metrics, system, application, logs, transaction traces, events, and so on and so forth, right? And the next is, what kind of analysis do you do? If you want to go fast, you actually have to do less and less complex analysis, right? So you look at static thresholds, you say, okay, is there architectural regressions or not, and so on and so forth, right? So if you think about it, if you have a less number of metrics, a simple analysis, you can do it manually. The moment you have a lot of metrics, and a slightly more sophisticated analysis, you actually need some sort of automated decisioning analysis. And that's what sort of motivated us to look at this problem. Now, I mean, you know, I have a toddler and he wants to do everything faster. So it's like, okay, how do we go faster? Now, just think about it. If you have tens of metrics per service that you collect, then you can still probably do a manual decisioning and it's still safe. If you have hundreds or thousands of metrics per service, you actually have to figure out which metrics is important, and you need a lot of application context. Now, the rate of change is higher than you actually, so this is the red zone, pretty much needs automated analysis. And if you have microservices or you have a large number of developers, you need automated analysis. That's, I think, why I think automated decisioning is a big part of continuous delivery. Now, luckily, Spinnaker has both ACA and Canary. These are the automated judgment and analysis stages. I'd like to call the ACA the manual judgment assist. Essentially, what it essentially does is that, actually, I'll cover it in the next slide. So ACA works like this. If you have a new release and you have an old release, and you deployed your old release yesterday, and you put your new release today, it essentially takes the context, the data exhaust from yesterday and the data exhaust from today, and makes a judgment on whether this is good or not. Now, that's a complicated question. How do you decide is a much complicated question. And I'm happy to talk to you guys offline as to what are all the things that we do. And this can be also be used for testing, load and staging environments. So if you have an existing deploy strategy, let's say red black, you can just add an ACA stage to it, and then the ACA stage can be used to help you make decisions better. So essentially, if you use, let's say, OpsMX and ACA stage, ACA analysis, and there are several others, other people also have other automated analysis. It looks at yesterday's or some other predetermined baseline red black and makes the decision about whether this red black is good or not. You can also use ACF to extend your testing and staging environments. So let me talk about, my motivation at the end of this talk is some of you will go home and try ACA. That's my motivation. So that means I need to tell you how to configure it. It's very easy. It's a 3-step process. You turn on a feature flag, and there's a nice blog here that tells you how exactly to do it. And then the way you enable canary is in MIME, in the Orca YAML, you insert the base URL that points to the analysis engine. I think somebody asked a question about monitoring. The next is monitoring. This is OpsMX specific analysis, so you can come into our analysis tool, our product, and essentially give us your monitoring credentials. We also have ability to, you can point to AppDynamics, you can point to other monitoring systems which you have, or you can use our monitoring agent. But this is a very easy step process. If you're in any of the cloud environments, you just need to give us the credentials, and we essentially Spinnaker would exactly tell the decisioning plugin what exactly to get and what metrics are being monitored. We figure all of that out and simplify the process for you. Then the third is the easy step. For each of your pipelines, you add your ACA task and then specify the ACA configuration parameters.
Make it as part of a template.
Okay.
Make it as part of a template.
Yes. The third is to then you run your pipeline. The way you run before is just that in your manual decision, you can use the scoring that you get from ACA, essentially automate or help use automated analysis for your existing pipeline. Canary is so this is the ACA. Now the Canary stage, essentially Canary would work this way. You deploy your new release for a fraction of your traffic, 1%. So you have V1, which is the new release, and the V0, which is the old release. You essentially have a load balancer. And so what in the Canary stage, what happens is that the analysis engine would look at the V1 and V0 and make a judgment on how similar they are and if there's any risk within that. So there's a comparison that you do for the same releases, but we also do we specifically OpsMX does some underlying analysis. In the case of ACA, you see it's the old release ran sometime distant in the future, so you need to normalize certain parameters to make sure that you're comparing apples and apples. So here the first two steps are the same in configuring the Canary stage. For an existing pipeline, once you've done the first two steps, which is turning on the feature flags and adding the base URL to the YAML file and the monitoring, then you add a Canary stage. So this is the screenshot of a Canary done. in this case, when the canary, as it's running, the analysis engine, whatever it is, keeps on monitoring and analyzing the metrics, that's the metrics, logs, and events potentially that's coming from both the baseline as well, the new release as the old or the current production deploy. And then we make judgments. If it is, you can set parameters such as this is the minimum threshold and so on. You can make some configuration parameters. Based on that, we either pass or fail. And if it fails, then you terminate the canary. So I'll show a quick demo. And you can also ask me questions as we go along. So this is your favorite Spinnaker console. So in this demo, you can assume we configured the Spinnaker, and also we set up OpsMX as the decisioning engine. Now, I'll show you how you can take your existing red-black. This is your existing red-black, and you can if you look at this. So this is your existing red-black, and you've inserted an ACA stage, and as it is running, we give you a score. Now, let's see a failed or an ACA that's given a warning or failure. So we have an ACA task that's an 80 score. You can set the threshold. In this case, the threshold of pass is 85. Then if you want to see a report as to what exactly happened, why it's 80, typically this is our user interface. You go here and you say, okay, we have a mechanism of telling you how to diagnose your problem. So you go and say, okay, I want to see the high relevance fail. Then in this case, you go and see that the DB operations has failed. Essentially, what this is telling you is that there was an architectural regression. That means yesterday's build and today's build for the same API, there's a significant difference in the number of database calls has been made. And so that's what it's telling you. You can look at it, and obviously there's other things like logs and so on and so forth you can look at. So that's the example of an ACA. The second example would be, let's say, a canary. Now, this is a successful, we inserted a canary, and in this case, this canary ran successfully. So it's a 91 score. Let's look at a canary that ran unsuccessfully. So if you go here, this is a 70 score. So this would have, the canary would have been killed. In this case, you go to the canary report. Here, basically here, and then you look at, you'll once you look at this enough, you'll know exactly how to diagnose query quickly. So in this case, you see this is a failed metric. And then, so what this is essentially telling you is that the rate at which the memory has, for a certain API, for a certain part of the testing, actually in this case, deploy, has accelerated significantly enough that we've caused it to fail. So this is a classic memory leak. So I've just showed you simple examples of an architectural regression, which is fairly common. Memory leak, which is kind of less common. So if you step back, what we've done is, if you want to go fast, you need some amount of automated decisioning. Now, there are two ways to do it. You can take your existing process and add a decisioning that you can use as a human being to make decisions, which is the ACA. I mean, I'm sort of dumbing down the message. The second is the canary, which is essentially the analysis engine is talking to Spinnaker itself to make decisions on your behalf. Obviously, you need to set a lot more parameters. So that's what I have, but I'm happy to take your questions. Yes.
So how much time does your engine need to get a valid signal? I saw that thing ran for 42 minutes.
Yes. So the valid signal depends, right? So there are two. One is just actually there are three things. One is what we call a univariate analysis, which is if, for example, if the memory metric has accelerated beyond a certain thing, you don't need a lot of time. You just can tell, right? It's a univariate analysis. Second is you compare this to something else in the past. So as long as you have equal samples, you're fine. Third is to learn from all the runs. That takes a little more time, typically about 3 hours of total learning time. Now there is also, you can complicate it further and saying, okay, I'm not just looking at this stage, but I'm also going to get some metadata from the previous stage, like I think you were referring to earlier. And that gets a lot more complex. And then you can add rules on top, your very custom specific rules. And so on. So we also have a concept of learning that this is a certain system and saying, okay, H-based, this metric should behave like that. That can cut across sort of companies and requirements, right? Sort of that's the democratic learning that we want to bring in. Yeah. So another way to answer your question is, first, we don't need much time to get value. That's the question. You don't need much training to get value. You can get a lot of value, and we've seen it in some of your customer deployments. Yes.
So this is a different question, right? I foresee a business problem here. Let us say I'm just kind of coming up with a business problem, right? Where business is kind of pushing IT to push certain build into the production because they need to communicate with the customer or the contract manufacturer or something, and then the business says you would solve your problem later, but they want some certain things to be done ahead of the time, right? Because they have some commitments. Now here in this case, let us say canary analysis fails for certain reason. Is there a way to still override it and push the build still so that they take care of the business problem and then come back and do analysis?
Yes. I mean, yeah. Spinnaker itself has all the controls necessary, right, all the way from ignoring the score to ignoring the errors to, we can construct parallel pipelines. I think Greg is the best person to talk to.
It's fully configurable, right? What is the fail score even? 85 may be too high for you. Because based on your past data, something changes all the time and nothing really. Well, that's one thing. Second thing is you can decide what are the execution steps when a particular stage fails. So that could be continue on or to terminate the pipeline.
I mean, I think the another way to answer that question is within Spinnaker itself, there are controls for sure to be able to make it extremely flexible. And that's what I love about Spinnaker. The second is when we give the score, we also want to give you an assessment of risk and saying, okay, what does it mean? If you want, and as you I haven't shown you all of it, but as you dig deeper, you really want to say, hey, is it worth taking the contractor? I mean, sort of, is it worth releasing? You want to have a more educated risk assessment. Today, you don't have that because manually you can't as much analyze, right? You don't know. That's.
Andy, what do you have seen from your Netflix? When you guys release products which have canary failures?
Chris or Greg?
Yes. Oh yeah, all the time. Well, it comes down to the, to your point earlier, maybe memories regressed to a statistically different amount. I mean, it's a manual judgment step in service owner says, we need to get this feature out, we'll come address the memory leak later. So yeah, we see it as well. So there is still some manual interpretation that even goes on, even at Netflix in our automated pipelines as well. We may flag from our platform that this build has regressed beyond some statistical certainty. And our service owners will judge, like Greg here will maybe take that and say, it looks good enough to push in production, and maybe they'll loop around at a later date, hopefully, and readdress the issue.
So a follow-on question on that then is, let's say you do say, torpedo full steam ahead. I know this was a poor release. Is there a way of telling your system, I know it's a poor one, that's not my new baseline?
Yes. Yes.
Okay.
Definitely.
And some of the changes could be intentional, right? Maybe not the memory leak, but that's not maybe intentional. But some of the behavior performance or database queries and things like that could be intentional change. So we do flag it, but then you can say this is minimum.
Yes, but in that case, like for instance, all of a sudden we're doing a lot fewer DB operations. You might say, well, that's because we wrote better code. And so you want to then say, okay, yeah, that's my new baseline. But then the other times is like, no, that's not. That's
not the baseline.
Ignore this one for the purposes of level setting.
I mean, practically, you have to be able to do that, right? I mean, that's practical. You need those controls of saying which one. Absolutely.
So when I was talking about kind of the vision of more intelligent, systems and fewer, knobs and dials, one issue we regularly run into is, how do we define what metrics are important per service? And, again, I keep looking to them because they can certainly fill in a lot of the details, but suffice it to say that across Netflix, different services are looking at different metrics. And so there could be a perceived kind of burden to say, I don't know what metrics are important for my app because it's a brand new app. And so does your system have kind of like, let's say, a default template to say, hey, look, maybe you haven't figured out what's important, but we have determined through all, 100 billion other analysis that memory and RPS and blah, blah, blah are important?
Yes. So we come up with a cookbook that's pretty much you can get going with running. But we also do, remember I said we will need some data to our data. Then what we do is, like, for example, one of the pilots, we get about 2,000 plus metrics a service, right? So now they're saying, okay, how do we know how you're going to, what is the signal, what is the noise? And so we need to learn that. And that also we need to know, because we can only learn from what we've seen. And it's a black box service, and actually these guys are very smart. They actually create faults and they see if we pass or not, right? So one is we believe that there has to be something that's like a cookbook that comes off the shelf, off the bat, and then it could also be based on, okay, this is a HBase, this is this, we know this. The second is, okay, we are seeing enough of these releases, enough of the flags, and okay, how do I learn of these 2,000 what makes sense, and how do I construct that into a score, right? So yeah, we do.
And there's one part of dimension reduction. So the score has to be meaningful. Not every metric has the same value, same relevance to a particular.
I mean, it's a hard problem. I mean, it's not. Don't get me wrong. I mean, it's not like we get it right all the time, but that's sort of.
Can't be that hard if Chris is working on it.
Thank you. So you may be looking for that new job after.
So sometimes the platform itself is generating hundreds of metrics. For example, you guys use Districts or a bunch of other platforms. As a developer who is deploying these services and looking at all these metrics, they get overwhelmed, right? The new ones,
right?
Say which ones to look at, and half of them look the same. So this system, the way we do it is we compare it over time. We do the analysis and say which ones of these metrics are all similar groups. That's one kind of analysis that we do. So we take, based on the load metrics, we do additional analysis to say which ones really are specific to these surveys that are really changing and which ones are not at all relevant to this particular surveys. And so that we bubble up, we can reduce to 10% of the metrics of the total. Say these are the only ones that are really changing for your service, and then analyze on those.
Yeah.
And within that also we can give certain amount of relevance. That's not perfected yet, but it does give a certain amount of relevance. I think one of the screens shows that. So that gives a help in
Diagnosing faster.
Well, I think you also added, maybe you said it was coming, but the whole notion of risk. I think that to part of the answer here is, hey, look, trust your gut, but here's a risk score. I suspect that risk score goes down as you all learn more, or your system learns more.
Yeah, absolutely. Confidence and risk is.
So this is again one of those questions which I might look like an idiot, but I'll go ahead anyway. So
We are all.
the notion of Spinnaker, right, that responsibility stops at the release point, and that post-release, when it's in production, that's not Spinnaker's job. Is that a correct understanding of?
So Spinnaker does have infrastructure management features, so you can look at your running app, you can affect that running app. Use the phrase or the word responsibility. I wouldn't say that's kind of a strong word, but certainly Spinnaker allows you to do that.
Well, it's the tool that you use to delegate, you manage your responsibility within the context of the tool. That's what I meant.
So Spinnaker certainly does that.
Right. So then the question is, these metrics that we're using are from post-release or from pre-release? And that is a little confusing as a newcomer to Spinnaker at this point. Finding it, I'm not reconciling, at least from what I've heard.
Two pieces. One is a production monitoring. The one that I think you're referring to is in a production, someone operations is managing.
Yes.
It's a system that's running. That monitoring, they have certain metrics that they define KPIs. Yeah. This one is primarily focused on deployment. As the new releases are coming in, new versions are being deployed. Are they being deployed with good health? Right. So that is where this primary focus is. So even while deploying, we are running an automated analysis in testing, staging, production. You could have a number of these stages. At each of these stages, you could still be collecting all these metrics and still doing analysis. So here, let's say at this end, it's in production, you are doing red flag. After you do the red flag, you want to make sure your deployment is up to the mark. So that is where the automated analysis is coming. After the deployment, after you approve the deployment, any anomalies that occur in production are not being captured. This one is only saying the new releases.
Basically, whichever stage you're applying the analysis to, you could apply it theoretically to any of the stages.
Fair enough. So then you mentioned, Andy, a little while ago that Netflix has a lot of other tooling that they built on top of Spinnaker. Is that the purpose of the tooling? It takes it from taking the feed forward after production, when it's in production running time, that it gets some of that back in the release deployment cycle. Is that the kind of tooling? Among other things I would do. Okay. Thank you.
So who's signing up for ACA and Canary? Cool. Thank you.
You already signed up. Thanks, Gopal.
Right, thanks very much. I think there's enough pizzas left still, right? Take it home. All right.
Have some pizza.
Thanks, guys. So look out for the next meetup. Hopefully, if anybody of you want to present user stories, happy to. Symantec or Chuka, don't run. I want you to present.
Thanks for coming, everyone. Seriously, thank you very much. All right, so we get turn this off. Yes, sir.
We don't use how. So it's